Okay, so now we're going to do a problem that not only has a dampening effect, but it's also got an external force acting upon it. Okay? So we're going to have a 16-pound weight. It's going to stretch a string 16 over 3 feet, 16/3 foot. And so there's a damping effect equal to 5/2 of the velocity. Okay? And an external force, F of t, which is going to equal sine of t divided by 2. Okay? So we're going to find the equation of motion of the objects, the equation of motion if the object is released 1 foot above equilibrium with a downward velocity of 2 feet per second. Okay? And so let's see what information is given in this problem. So this is really the equation that we're dealing with right here. So we need to consider the mass, the spring constant, the damping effect, and F of t, which is the external force. Okay? So let's look at the different bits of information that are given inside of this problem so that we can figure out all of this. Okay? So M is just the mass. Okay? So M, all right, so first we're going to find mass. Okay, M is going to be weight divided by gravity, which is going to be, all right, so it was 16 pounds, so it'd be 16 divided by 32, okay? And then Hooke's law, or say the spring constant. Okay? So, all right, it weighs 16 pounds and it stretches at 16 divided by 3 foot, okay? So that would mean that K would equal 3 pounds per foot. All right, so then we have to talk about what is the damping effect. Okay, that would be my beta, which equals 5 divided by 2. Okay, and then my external force, okay, that would be, I used big F over that, I think. Big F of t is going to equal sine of t divided by 2. Okay? And let's also consider what the initial conditions were. All right. So the initial conditions was it's released 1 foot above equilibrium. So if it's above equilibrium, it's going to be negative. Okay? So x of 0 is going to equal 1. Okay? And it's 1 foot above equilibrium with a downward velocity of 2 feet per second. So it's headed down, so it's headed towards the bottom region, so that's going to be positive. So that's telling me that x prime of 0 is going to equal 2. Okay. All right, so let's go ahead and just set up our equation. All right? Oh, wait a minute. 16 divided by 32, that simplifies out to 1/2. Okay? So, from all that information right there, that's what we need to solve the problem. All right? So, let's say this is 1/2 all right, so my K was 3, so that's going to equal negative 3x, okay? And then my beta was 5 over 2, so that's minus 5 over 2 dx dt, and then plus sine of t divided by 2. So that's m, k, beta, and the external force. All right? Let's move these guys over to the opposite side of the problem. So I would have 1/2 times the second derivative of x with respect to time, now plus 5/2 dx dt, okay, plus 3x is going to equal now sine of t divided by 2. Okay? Okay, all right. We want to get into standard form, so go ahead and just multiply the whole thing by 2. Okay, so now we have a non-homogeneous second-order differential equation. And so remember, with a non-homogeneous second-order differential equation, the first thing that you're going to do is you're going to solve for the homogeneous portion of the problem to get the complementary solution. And then what I'm going to do is I'm going to do a method of undetermined coefficients to then try to find the particular solution. Okay, so for the homogeneous portion, we're going to have m squared okay, so I can factor that. Okay, so m1 is going to equal -2. And m2 is going to equal -3. Okay. So x sub c is going to equal c1 e to the minus 2t plus c2 e to the minus 3t. Okay. So that's our complementary solution. Great. All right, now we need to find the particular solution, okay? So we're thinking about this problem right here. So when I look at the right-hand side of this problem, well, actually, because it's not part of the complementary solution, that's a good sign that method of undetermined coefficients is going to work. So I'm going to guess that x sub p is going to equal now a plus b cosine t. Okay. So since we had sine on the right-hand side of the problem, you need a sine t and b cosine t because whenever you take its derivative, sine turns into cosine. So that's why you need both of them. All right. Okay, so then I'm going to look at the derivatives of this. And the second derivative as well. And so the problem that we're looking at is x sub p, it's going to look slightly different, plus 5. Okay. So that would equal, so negative a, now sine of t, minus b cosine of t. You know what, I'm going to write it vertically so I don't confuse anybody. Now plus 5, okay, that would be a cosine of t plus b, minus b sine of t. Okay? And then plus 6 times just x of p, which would be a sine of t plus b cosine of t. Okay, so let's look at what we can combine together. We can do this in a couple of steps. Since this one is the same as that one, I'm going to combine these two and then just leave this one alone for right now. So if I have 6a sine of t and I have negative a sine of t, what is that going to become? Okay, now I'm going to write this line first. Okay. And now I'm going to combine this line and this line. So negative a sine of t and 6a sine of t would become 5a sine of t. All right? And now 6b cosine of t and minus b cosine of t, that would turn into plus 5 okay, and now I can combine them further. So that would give me, okay, so 5a plus 5b, now cosine of t, and plus, now this would be 5a minus 5b sine of t. Okay. Okay, after all of that, we're going to set it equal to the right-hand side. So this is going to equal, well, 0 times cosine of t, and then just plus, well, 1 times sine of t. Okay, so this is going to give me two equations. Okay, so we have 5a plus 5b equals 0, and then 5a minus 5b is going to equal 1. Okay, so that means if I add these guys together, that's going to give me 10a is going to equal 1, or that a is going to equal 1 divided by 10. Okay, now if I plug a into this, imagine you have 5a plus 5b is equaling 0, and a is 1 over 10. Well, you can subtract negative 5 over 10 to the other side, and then divide by 5. Well, b would equal negative 1 over 10. When you think about it, that makes sense. So you plug that into this, you get 1/2 plus 1/2, which equals 1. Okay. Okay, we're not done. Okay, so what do we have from all of this? We have that x of t is going to equal now c1 e to the minus 2t plus c2 e to the minus 3t, okay? And then plus So a sine of t must be cosine of t. Yeah. Okay. That would be sine of t divided by 10 minus now cosine of t divided by 10. Okay. And so let's start using those initial conditions. So we have x of 0 is going to equal negative 1. Okay. So that would give us the negative 1 is going to equal c1 plus c2, and then minus 1 over 10. Okay, because cosine of 0 is 1, sine of 0 is 0. So if I move the 1 over 10 to this side of the problem, that's going to be negative 1 plus 1 over 10. So that's negative 10 over 10 plus 1 over 10, which is negative 9 over 10. That's going to equal C1 plus C2. Okay, that's slightly helpful, but let's go to the next point. And so let's take its derivative, and we're going to use the initial velocity as the other condition. Okay. So now x prime of t, that's going to be, all right, so negative 2 c1 e to the minus 2t minus 3 c2 e to the minus 3t. Now the derivative of sine is going to be plus cosine of t divided by 10. And the derivative of cosine is negative sine, so that would become plus sine of t divided by 10. Okay? So now our other condition was that it was moving downwards with an initial velocity of 2 feet. Did I get that? Feet per second, yes. So that means that 2, okay, all right, that's going to be negative 2 c1 minus 3 c2, and then plus 1 divided by 10. Okay, so if I subtract 1 over 10 from both sides of this problem, this 2 is really 20 over 10. So if this is 20 over 10 and then minus 1 over 10, I'm getting that 19 over 10. Okay, so we're making a little bit of progress, but we need to take that other equation that we were dealing with, which is this negative 9 over 10, which equals C1 plus C2. What I'm going to do is I'm going to multiply this entire thing by 2, so that then when I add it to this one right here, they're going to cancel each other out. So this is going to be negative 18 over 10 is going to equal now 2C1 plus 2C2. So now I can add these together. So 19 over 10 and negative 18 over 10 is going to become a 1 over 10. And so 1 over 10 is going to equal negative C2, where the C2 is going to be negative 1 over 10. Okay? Okay. Let's go back to which would be easiest to deal with. Okay, so that's probably easier to deal with. So let's bring it into the first one. So negative 9 divided by 10 was going to equal now C1 and minus 1 over 10. Okay, so if I add negative 1 over 10 to both sides, add 1 over 10 to both sides, that's going to give me that C1 is going to equal negative 8 divided by 10. Okay. So after all of that, we actually have the solution to the problem. So that tells me that x of t that's negative 8 over 10. That's going to equal negative 8 e to the minus 2t, minus 2t divided by 10. And the other one was negative 1 over 10, so that's minus e to the minus 3t divided by 10. And then plus, that's going to be sine of t divided by 10, and minus cosine of t divided by 10. That's the full solution to that problem.